Good evening. Welcome to this webinar in what's turned out to be an absolutely wonderful first webinar series presented by the Newton Conservators. As most of you probably know, Newton Conservators is a nonprofit established in 1961 that works to preserve and to maintain open space in Newton. For more information about the organization, please check out our website at newtonconservators.org. We'd love to have you become a member while you're there. New members get a Newton Trail Guide as a welcome gift. My name is Beth Wilkinson, and I'll be the moderator of this virtual event. Barbara Bates will provide technical assistance. With that business out of the way, let's turn to the important part of the evening. Joining fern expert Don Lubin for an explanation of why ferns are important to our planet and how to recognize the most common ones in New England. Don has been growing ferns since 1980 and doing field identification since 1991. He has led fascinating workshops and field trips since 1998 for the Native Plant Trust and others. Don assisted Cheryl, Lowe, and Elizabeth Farnsworth, may she rest in peace, in their revision of Boughton Cobb's Field Guide to Ferns, and is a co-author of the Newton Conservators Almanac and other publications. Let's explore the world of ferns with Don. Welcome, Don.
Hello. Yes, I am Don Lubin. I like to find wild ferns and show them to people. I have been leading workshops and walks and lectures for 20 years about how to identify native ferns and their relatives. I grow dozens of kinds in my small city yard and collect specimens for herbaria. I maintain a website on New England fern information and identify observations on the iNaturalist website. I've worked with Newton Conservators for 16 years. For a while, its land management committee would survey a different natural area every week. The compiled results are online on the Newton Conservators website so that you could see, for example, what ferns we have found in each conservation area. I had a little trouble finding where it is on the Conservators website. It turns out it's on their homepage at the very bottom left corner where it says walks. Click on that and it becomes clear. I did help write the almanac, a cute little booklet if you haven't seen it. We have seen 28 ferns, club mosses, and horsetails in Newton. The best places to look are Webster on both sides of Hammond Pond Parkway, Cold Spring Park, Nahonton Park, Kennard, and Flood Meadow. These are coincidentally places where I've led walks. So, ferns are an important portion of our ecosystem, though they comprise less than 3% of our conspicuous plant species. They don't have very much economic impact. They are pretty and lend a delicate texture to some of our landscapes. They're more common here in New England, north of the terminal moraine, especially in wetter areas. They were pivotal in the development of life on Earth and have an enduring critical role to play. I'd better go at this point to share screen. The URL is nefern.info. It's this portion right here. .info. So this is a front page, and if all you want to do is look at the pictures, you click that. If you want to see about ferns and stuff, you click more, and you could see about my garden or classes that are coming up. But if you want to know about ferns, you click ferns. And then there's lists of various sites, including, say, Massachusetts, and what ferns and club mosses and horsetails grow there. Or you could look at all the taxa in New England of the pteridophyte species and some of the hybrids. But this is a talk about the introduction. So this is a picture of life on Earth and how it's categorized. And the first to exist were bacteria, little single-celled creatures, plants, which we'll talk about more, fungi, and animals. That's pretty much how they're categorized. We're talking about plants. The first plants. There were algae, mostly in the ocean, maybe some in lakes for a long time. Eventually, mosses figured out how to leave the bodies of water and come up on the land. They developed a waterproof coating. They couldn't get very tall, though, because water had to enter the tissue from the air. There are pteridophytes, which include ferns, and then spermatophytes, which are the most common plants today. They're gymnosperms, the conifers. I don't know if this is hidden by the people as it is on my screen, but, and there are spermatophytes, which monocots and dicots are the main categories. But we're talking about pteridophytes. Pteridophytes propagate by spores. Spermatophytes grow seeds. Gymnosperms, it's seeds inside the cones. Pteridophytes consist of horsetails, club mosses, ferns, and then two smaller groups, Selaginella and Isoedes. Isoedes mostly grow in mud or even at the bottom of ponds. Selaginella, there's only 2 or 3 species in New England, and they're pretty obscure. Even if you're standing right on top of them, they're hard to find. Horsetails are, some consider them a kind of fern. They evolved at about the same time. They have joints like bamboo. Club mosses probably evolved first, and they have little needles. Ferns are the first to evolve leaves, which is a very important invention. These are the solar panels that power pretty much all life on Earth these days. There are 12,000 species of ferns in the world, about 53 in Massachusetts. Most of them are tropical. Most ferns in the world are tropical. Ferns can be 2 inches tall when fully grown, or 80 feet in the case of tree ferns in New Zealand. Around here, I've seen 3 different species go about 7 feet tall, which is taller than they usually do. We have 1 species, at least occasionally in Massachusetts and more commonly farther south, a climbing fern that's actually a vine, and it'll go up 25 feet if it has a tree to climb. Otherwise, it'll go up about 1 foot. So people eat fiddleheads. Florists use the fronds in bouquets. Some people use ferns and club mosses to try to absorb pollution. There are some medical uses. And before electronic flash, before flash bulbs, in the really olden days at the beginning of photography, they would have a pan and light it on fire to get the light for the photograph. And what was burning were spores of club mosses. They have a very oily coating. Spores don't have the same kind of stored food that seeds do, but to give the juvenile, the infant plant, a little bit of head start, the spores are coated in something oily, more calories per gram than other. Here's another way to look at categories of plants. They're the algae that reproduce by cell division. And mosses develop not only the waterproof coating, but also they adopted a zygote that some algae have to swim off and start new colonies. Bryophytes invented spores, a really waterproof coating over the germplasm. Pteridophytes still have the spores and developed a circulatory system, which was very important so that they could get taller than about 4 inches. And once they developed that, they grew to about 6 feet, after which they would fall over. Spermatophytes kept the circulatory system, phloem and xylem, and some trees get quite tall, even taller than the ferns, which were, after they invented lignin, which is, you may have heard of lignite as a soft coal, then they had the strength to grow more than 6 feet tall and grew to about 120 feet was the maximum in the Carboniferous area when the coal seams were laid down.
Don, what is the origin of pterido and pteridophyte? What does it mean?
It means feather.
Neat.
Some people think that ferns look like feathers, some more than others. And it's from the Greek. The whole group of plants was named after that concept.
Thank you.
Sure. So quickly, I will talk about the timing of all this. The Earth solidified, cooled down enough for anything else to happen about 4.6 billion years ago. And pretty soon, 4 billion, 3.5 billion years ago, life arose, mostly in the form of bacteria. And then for most of the rest of the time we've had, that's all there was. Some of the bacteria learned how to do photosynthesis, cyanobacteria, and very slowly split the carbon dioxide that was pretty abundant and made free oxygen, which spent billions of years converting the iron ions in the ocean to rust. And it took a very long time because there was a lot of iron in the ocean. And the iron oxide would settle to the bottom. And anytime you see red rocks or red clay. That's what that is. So then about 500 million years ago, there was so much oxygen available that different kinds of animal families could evolve, and it started to leak into the atmosphere. And so a little over 500 million years ago, Cambrian explosion, lots of new life forms and mosses. And then about 4.25 million years ago, club mosses, and then ferns, horsetails, the other pteridophytes started. That's when they invented the circulatory system. And here in the Carboniferous age, a little over 300 million years ago, ferns were at their peak. There weren't any flowering plants yet. They didn't evolve until about 100 million years ago. So for 3/4 of the time that there have been vascular plants, it's all been ferns and then gymnosperms too, but the flowering plants are relatively recent on this scale anyhow. Here is a fossil of a fern, and I have a couple that are very similar to this. This is probably from north central Illinois, where the coal seams were fairly near the top, and companies would just strip the shale off the top and dig out the coal, and then just leave it that way. Really ugly scars. But there were nodules of the shale lying around, and some of them had fossils in them. Actually, if you tap the side of a nodule, if there is a fossil in them, it'll split right where the fossil is because there's no rock holding it together where the fossil is. So this is a leaflet, a pinule probably of a larger fern. So ferns also, and the relatives, invented other things besides leaves in the circulatory system. They were the first plants to really produce a lot of organic material. So when that fell into the mud and the sand and got ground up and added to it, they invented soil. Sand isn't soil, mud isn't soil. It takes organic material included. These ferns and their relatives invented coal. All the coal we have ever had was laid down pretty much in the Carboniferous era, about 300 million years ago. And then after a while, fungi figured out that they could actually eat the lignin. Lignin is pretty tough stuff, but once the fungi figured out how to do that, then it didn't all pile up and turn to coal. It got eaten first and put back into the soil. What else did they invent? Well, by having broad leaves, they could photosynthesize much more effectively and put lots more oxygen into the air. And there's oxygen content over time, 600 million years ago. Now we have about 21, 22% oxygen in the air. It got up to 35%, a little more. I'm not sure it was really that high earlier, but So besides soil, these plants invented air as we know it. With so much oxygen, once you have a fire, it doesn't go out. Had huge forest fires. These plants invented charcoal. Something a little more subtle that they invented were rivers. What do you mean? He invented rivers. Water was flowing before that. Yes, and it would flow just all over the plain. It would meander, like some of the rivers still do. The Mississippi creates oxbow lakes and changes course regularly, but with tall plants holding the soil down along the edge of the watercourse, it doesn't meander nearly so much. If it's just running all over the plain, then you can't really develop an ecosystem. It gets washed away before it can fully develop. But once there are plants, sturdy plants, to hold the river in place, it's a different story. And the other thing that I would attribute to these plants, by putting food out there on the land. Oh, I didn't mention the circulatory system not only lets water get up to the top of the plant, it also lets air, oxygen, go down into the roots of the plant. So you can have roots of the plant that don't rot. So you can have deeper roots. So these plants can move away from the very edge of the swamp and really invade the land as far as they can still reach the water table. And some plants have pretty deep roots. So with the food covering much more of the land and the air oxygen content high enough for animals to be active, these plants invented land animals. They couldn't have any before. So let me digress at this point and tell you what's really important about ferns, not just that they're pretty. We have all picked a good planet to live on. Earth is in the Goldilocks zone, where water is wet, not steamy like Venus, not frozen like Mars. And there's a lot of water, 71% of the Earth's surface, a bit more every day. Water is significant because its two hydrogen atoms stick out on the same side of the oxygen atom, you know, H2O. So the molecule has negative charge on one side and positive charge on the other, which lets it pull a lot of other molecules apart and dissolves them. And so all sorts of elements get a chance to interact in liquid water. We also have a lot of land that we can run around on or sink our roots into. The land surface has on average a much higher concentration of life than the ocean, maybe 1,000 times as much. The Earth is so large that it has enough gravity to hold us down. We don't just float around, but it also holds our atmosphere in place. That's very important. Look what happened to Mars. The Earth has a molten iron core that is spinning, that creates a magnetic field that is able to divert the solar wind to the north and south poles. We get aurora instead of excessive ionizing radiation, which would be very dangerous. We have a large moon in circular orbit. Yes, it gives us tides, but it also holds the spinning Earth in a stable orientation, limiting its precession. So the seasons we have are very stable over long periods. Ecological habitats can develop and persist without polar ice caps meandering across the Earth's surface and wiping them out. It's good to have the ice caps stay at the poles where they're supposed to be. Earth is protected from frequent collisions with comets and such by the large planets farther out, Jupiter and others, which sweep away the comets from orbits that intersect our own. Doesn't always work, but very often. And our solar system is located in a fairly quiet neighborhood on the outskirts of the Milky Way galaxy, without the dangerous collisions of stars and the radiation at the galaxy's core. 8 important advantages. It's a good place to live. And yet, life on Earth has suffered at least 5 mass extinction events, maybe more, when a majority of Earth's species disappeared forever. The universe is a dangerous place. Collisions with comets or whatever, extreme volcanic activity, it's been rough. In the last extinction event, 66 million years ago, when the dinosaurs finished dying out, North America was particularly hard hit. Flowering plants disappeared from the continent. Too much fire and sulfuric acid rain and darkness for too long. Pollen abruptly disappeared from the geological record. The layers of mud that are deposited. But soon there was a fern spike where fern spores replaced the pollen. I mean, there were always some there, but at a low level. Fern spores, lighter than seeds, that can be carried across oceans by the jet stream. Spores so invisible that the last starving birds and rodents couldn't eat them, couldn't see them. Ferns repopulated the world, rebuilt an ecosystem, created an environment where flowering plants and animals could slowly recover. There was a fern spike also after the previous extinction event 200 million years ago, and smaller such spikes after local extinction events, such as Krakatoa or Mount St. Helens. We are currently experiencing another mass extinction event. Species are disappearing at hundreds of times the normal rate. The world has lost about half of birds, land animals, and ocean life over the last 40 years. Pollution, destruction of habitat, introduction of invasive species, ocean acidification, and now global warming. At this rate, Earth may need ferns once again to recover from a mass extinction. That's what I think is most important about ferns. Ferns, when they're growing, when they're young, have a special shape. It's a spiral. And it's actually a logarithmic spiral, such that no matter how large or small it is, it's the same shape. This is a cinnamon fern, fiddlehead. The reason that they have this shape is to protect the growth tip. I've been picking tomatoes and picking off suckers Every time there's an armpit, some new growth happens, trying to grow a new branch. Ferns don't have secondary growth. It's part of why they're pretty. They have a design, and they grow that design and don't add lip. So if their growth tip gets chewed off, they can't just grow more arms. They have to start over. Be a bother. So they protect the growth tip inside more robust, tougher, less appetizing tissue. And then they put some kind of armor on top. In this case, white hairs that kind of look like lint or fluff or wool. So I'm going to use some terms. This drawing, which I did not draw myself, is the most popular page on my website. I guess it's assigned in classes or when people Google search for parts of a fern. This is the easiest one to find. The whole part of the fern coming out of the ground is called a frond. It's a leaf, but it's a special kind of leaf that has the sori, the spore generating organs on the back of the leaf, and other kinds of plants don't have their seeds in the back of the leaf. This is different. It's called a frond. The part of the frond that actually has the leaf material, it's called the blade. Below the blade, the stem is a stipe or stalk. The midvein, the stem inside the blade, is the rachis. Each of these leaflets is called a pinna, and subdivisions of that are called a pinnule. The fiddlehead or crow's ear is this spiral when it's growing up. The frond is the equivalent of a leaf. The trunks, the branches, the twigs, all that is the rhizome, and it's underground. Well, in some pteridophytes, it crawls over the ground a little bit, but generally they're underground. And the roots, the rhizome isn't the root. The roots are little hairs that grow off the rhizome. Now, this rhizome can be horizontal, or it can grow up vertically. So my website is there for all to see, and if any of this isn't adequately memorable, you can go there at your leisure and look. Some fronds, blades, have sori on the back, the little organs where the spores grow. But some fern fronds don't have spores on the back. They're sterile. The fertile fronds on most ferns are taller than the sterile fronds because they have a different purpose. I mean, they can do photosynthesis, and that's fine, but their main job at the fertile fronds is to get up into the breeze and release spores where they can blow as far as possible from the parent plant. The sterile fronds, all they're really supposed to do is convert sunlight to food. And sometimes they'll almost lie on the ground facing the sky because that gets the most light. I will talk only briefly about the life cycle of the fern. Here are little sori on the back of some of the pinnae. And this is more or less what one looks like. Those are sporangia. Each sorus has several dozen sporangia. There's a picture of a sporangium where when it breaks open, spores are released. That's called an indusium, the covering that protects the sporangia until they're ripe, and then it just shrivels away. And then the sporangia can break open, and in fact, by using varying humidity in the air, they managed to actually fling the spores several feet up into the breeze. So if a spore happens to land in a good spot, by which I mean wet and not crowded with other things growing, it grows organs that create eggs and organs that create sperm. And sperm are released and swim to the eggs and fertilize the egg and grow a new plant. This alternate generation is tiny, looks like a little lettuce leaf. I mean, tiny in a couple of millimeters, centimeter would be big. One can notice that if these sperm swim to those eggs, you haven't really accomplished very much. All the genes in these sperm are the same as the genes in those eggs, or very nearly. And so it doesn't deepen the gene pool at all to do that. These sperm better swim to some other prothallus, some other gametophyte. But whether they do or not, this is the new sporophyte. It creates spores. This gametophyte creates gametes. And there's lots of more interesting stories to tell about that, but I won't. Vegetative reproduction accounts for most of the ferns you'll see in the woods. They just don't bother to have sexual reproduction. It's too laborious, too slow. They just send out a rhizome and start a new plant, or might have little bits of some sort or another that break off and wash away and start a new plant. Oh, here's a picture of Bulblet ferns. I don't know how well you can see this, but these are little bulblets, those two green things. And they will turn dark, and they will fall off, and they will roll away and start new plants. And I have new Bulblet ferns growing in the cracks of my sidewalk because they did exactly that. And you can just sort of sweep these bulblets off the sidewalk and give them to someone else so they can try to grow them. See, I think there's another example here. Walking fern is an interesting one. These are not such common ferns, but very narrow little cluster. Where this tip puts down, it can start a new plant. And you can see generations. Anyhow, they're cute if you ever get to see them. I used to have some at the garden in the woods. I might have like one left. They don't really do too well there. Moving on. So I maintain that there are three main things to look for when you're trying to identify a fern. And the first is the degree of cutting. And ferns are either not cut at all, or cut up to 3 times, or possibly 4, but basically the categories of ferns looked at this way are entire with no cutting, or once cut, like Polypodium, or twice cut, like Silvery Glade Fern. Actually, most of our ferns are twice cut, or even 3 times cut, once, twice, 3 times. It's an important concept, and some people take a little while to grasp it, but I think these pictures portray it reasonably well. Another thing to look for is the growth pattern. Some ferns have a vertical rhizome, and all the fronds grow out from a fairly small area. And this is an extreme form. This is Ostrich Fern, and it forms the tightest vase. The fronds actually face each other. That's a clustered growth form. The other extreme is Scented Fern, where fronds just come up willy-nilly. They make their own decisions about which way to face. The rhizome runs along horizontally and forks a lot. So you just get a mass of fern fronds with no particular relation one to another. A lot of ferns fall somewhere between these extremes, but so the third thing to look for, character. I told you that the fiddleheads have armor often to ward off predation. A few don't. It's called glabrous when they're just smooth. A lot of ferns have hairs. A hair is 1 cell in diameter. Some have scales that are at least 2 cells wide. They don't form cables either. If they're more than 1 cell, it's only in one direction. And then the Osmunda have these hairs that remind me of laundry lint. If you look closely, there's actually 2 kinds of ferns here, but we'll get to that. Some ferns are just so distinctive in the shape of the blade, like northern maidenhair fern, that you don't really need to look very carefully to see what it is. There are other maidenhair ferns in the world, in the country, but around here, this is what we get. All these pinnae are coming out on the same side of the rachis. So you get this horseshoe shape. Anyhow, that one's pretty straightforward. Another uncommon shape is a Bulblet Fern. Again, is so long and narrow. Bicycling down a hill in Western Mass on the bike trail, I screeched to a halt because there was Bulblet Fern, and I knew it was Bulblet Fern, which I hadn't seen yet that day because it was so long and narrow. What else? That's enough. Okay, I'm not going to talk about hybrids. They're very interesting. We do have some around. We have some in Newton, at least 2 different kinds. Maybe 3. Hybrids can mutate and form new species, and they do with ferns, but that's a whole separate subject. New England is a good place to look for ferns, if you're not in the tropics anyway, because the glaciers came through and ground up our rocks and put the nutrients into the soil. And if you get south of the terminal moraine, which runs through like the middle of Rhode Island, some of the later ones anyway, the fern diversity just drops way off. Driving back from a field trip to North Carolina, it wasn't until around New York City that we started seeing again ferns on the roadside. And it really wasn't until we got Massachusetts that there were a lot of them. At this point, I'm going to quit out of this portion of my website. Someone has a question about what we've done so far.
Our participant Andy had a question from the very beginning.
Yeah.
She wanted to know when you said that ferns were 3% of the, she wanted to know whether that's by species, by number of individuals.
By species. If you go by biomass, it's very much less.
Okay.
And that's for ferns. And club mosses, horsetails, the others too, but it's mostly ferns. And that's for United States and Canada.
I have another question. Then you said 3 species around here grow to be 7 feet tall.
Yeah.
Are you going to show them to us, or should we get a preview of what they are at this point?
I will show them.
Neat.
So here is a photomicrograph of the sori on a wood fern, on a Trioptarus. And there are all these sori, and usually with the naked eye, you just see these dots on the back of the front. So quick, write down the website URL. So as I was saying, with the naked eye, usually you can just see little dots on the back of the frond. They're called sori. But if you look carefully, like with a dissecting microscope, then you can see that there's several dozen of these little curly things, sporangia. And each of these sporangia contains about 64 spores for most kinds of ferns. And when these ripen, they'll shoot the spores out, and hopefully they'll blow away to somewhere far from the parent plant. Here's an indusium that covers and protects the sporangia, and it shrivels up. Shrivels up later in the season so that the sporangia get a good shot at sending the spores away. So I'm going to go through a number of species. Got some time left. This is Polypody. And this is actually Appalachian Polypody. We have 3 different taxa of Polypody in New England. I was amazed when I first learned that. This one is wide and pointed pinnae, widest near the base. Here's the other one. This one's tetraploid. This is Polypodium Virginianum. That one's Polypodium Appalachianum. It's narrower and it's rounded tips. Come on. And it's widest in the middle. And here's the 3 of them together, Appalachianum, Virginianum, and the hybrid, which is a triploid, and shouldn't be able to reproduce by spores, but it does it anyway, something called parthenogenesis. I won't get into that, no time for that. So here's another species. What I'm doing is going by the degree of cutting, and these are species that are almost but not quite cut once. The species that are entire are so uncommon around here that I won't show them. And here's another one. This is Scented Fern. It's very common. It likes wet and it likes bright. Even in the swamp, you won't see it much until you get either to a clearing where a tree fell over or the edge of the swamp where light is coming in. It's not quite cut all the way. It's called winged when the leaf material runs along the rachis. This would be more like twice cut if it were totally cut the first time. Some ferns are dimorphic. All ferns, the fertile frond and the sterile frond look a little different. The fertile fronds could be taller and they're certainly more erect. The sterile fronds, as I said, are just trying to photosynthesize. But some ferns, the fertile and sterile fronds are so different that they're called dimorphic, two forms. And that's the sterile frond, and that's the fertile frond. And those are the sporangia, and they will release the spores. And that's the current year, and that's the previous year. They turn dark. These emerge, these fertile fronds, in the middle of the summer, not in the spring. And then they hold the spores through the fall, through the winter, and into the early next spring and release their spores, most of them anyhow, around March. Why would they do that? Well, the spores, to grow, they're going to need to find disturbed soil. And winters can be pretty good at disturbing the soil, knocking trees over, just killing off whatever is there, gives these spores more of a fighting chance to compete. And so, one of the very easiest ferns to identify in February with several inches of snow on the ground is Scented Fern, because they have to stay erect through the winter. Everything else is underneath the layer of snow. Here's another fern. This is Long Beach Fern or Northern Beach Fern or Narrow Beach Fern that isn't quite all the way cut to the middle. This fern likes wet. Thing is, it's got a gap there. The leaf material that follows all the way down the rachis until there's a gap between the first and the second pinnae. And that distinguishes it from something called the broad beach fern, which is, well, we'll get to it maybe if we're quick. We're at pretty much the southern end of the range of Long Beach Fern. There used to be some in the fells, not very much, but no one's found it recently. I did recently find Broad Beach Fern in the fells. There's some of this at Mount Wachusett. There's some in Harold Parker State Forest. If there's a waterfall, you might see large colonies of Long Beach Fern sort of flowing down the sides of the waterfall. It's quite a sight. Here's Christmas fern. This is fairly common, a little more so if the soil is sweet. It's Christmas fern because it's evergreen, and some people have used it for Christmas decorations. It is cut all the way to the rachis. It has narrowed pinnae at the tip when it's fertile. There's a better view of the narrowed pinnae. And the spores, the sporangia, totally cover the underneath of the pinna. It's usually...
Those who aren't familiar with it, Don, what does it mean for soil to be sweet?
Okay, it means that it's not as acidic, which is mostly caused by something like lime in the soil. We don't have much limestone around here, but certain rocks, when they break down, make the soil acidic. And some trees, like oaks, when they break down, make the soil acidic. Maples, on the other hand, grow in sweeter soil, and the leaves make the soil still sweeter yet. There are various plants, not only ferns, that prefer the sweeter soil because the nutrients in the soil are more accessible than if it's very acidic. On the other hand, there are plants like rhododendron that really prefer the acidic soil. Anyhow, alkaline, they call it sweet. I don't think it tastes sweet. That's what they call it. So here is a crested wood fern, and it's about 1.5 cut. This is probably our fourth most common wood fern, Trioptarus cristata. And there's a fertile frond, and these are sterile fronds, and that's a sterile frond that's just facing the sky, but the fertile frond is trying to reach up into the breeze. And the easiest way to spot it is from this fertile frond that is very narrow, and the pinnae twist, so they face the sky, sort of like rungs on a ladder. It's like wet places, and occasionally you can find an area that has tons of it, but often there's just a couple of these plants at a time. Okay, here's one. So I put this in this order because its cutting is about 1.5. The first cutting is obviously complete, but the second cutting isn't. But here's one that is totally twice cut. And this is Ostrich Fern. And one interesting thing about Ostrich Fern, Matutia Stratiopteris, is that this is the only species of fern that it's really legitimate to sell for food. It's illegal in the US and Canada to sell any other species as fiddleheads. I mean, some people will eat whatever they eat, but what's sold in stores is this. And mostly in Atlantic Canada, also on the upper reaches of the Connecticut River, there are a great many areas growing in ostrich fern. It's called ostrich fern because maybe in this frond you can see the shape. It's widest right about there. It's widest above the middle. It's about the only fern that does that. It's the shape of an ostrich plume, narrow at the bottom and then widest near the top.
Are other ferns more toxic, or is it just...
Yeah, lots of toxins. They've had hundreds of millions of years to learn how to defend themselves. There are countries that eat, in some cultures, osmunda, some other kinds of ferns, and also have higher rates of stomach cancer than we do. And some people think that's why.
Fascinating.
Bracken is a fern, I'll show you towards the end, that is very bad. It is particularly toxic. Cows, oh no, it's easy to reach if you're a cow. It grows up tall, and they eat it, and then they get a stomach ache. It's a known veterinary disease to have cows eating bracken. It's an extreme example. Most of the ferns would take years to do you in. They're carcinogenic, but they're not immediately toxic the way bracken is. But this one is relatively benign, and I still prefer asparagus myself. But so like the sensitive fern, ostrich fern also is extremely dimorphic, and this is this year's fertile frond, and that's last year's fertile frond. And these also scatter their spores somewhere around March of the following year. Here's a twice cut fern called New York Fern. And what's unique about this one is these tiny pinnae that go almost down to the ground. And there are mnemonics to remember some ferns. This is New York Fern. New Yorkers burn their candles at both ends. It's by tapering. Pretty much if you see these pinnae getting tiny like that, and a fern that looks anything like this, it's a New York fern. There's some that are twice cut that look sort of like this, except they maybe stop there and not have any of these. The ostrich fern also has tiny pinnae down to the ground, but doesn't really look anything like the New York fern. This is not tightly clustered. It's one of the most ambiguous about whether the growth is in clusters or singly separate emergence. Here a picture of some of the pinnules of New York fern. You have to look very closely, maybe with a lens, to see these hairs which come off the edge of the pinnule. Notice the vein. There's the mid vein, and any vein that comes off the mid vein goes straight to the edge of the pinnule. Doesn't fork, just simple veins. Here's a fern called Silvery Glade fern. It's twice cut and looks sort of like other ferns, maybe lady fern from a distance. But if you get right up to it, what's distinctive are these almost oblong, very blunt-tipped pinnules that are all the same length. These are relatively rounded. Sometimes they really look squared off. And they have on the stipe white hairs, kind of long white hairs, that really go up into the rachis too, which would be very different from some of the other ferns that look sort of like this, like lady fern. So here's a cinnamon fern, and this is one of the most dramatic ferns we've got. This is one of the ones that can get to be 7 feet tall. If it has a lot of competition for light and it is in a wet area. And this was taken around Memorial Day. The end of May is when this blooms, so to speak. The fertile fronds are very distinctive. They don't have green sterile pinnae at all. Usually there's a form that does, but usually you get something like this, and these cinnamon sticks, just from the color is where it gets its name. Exactly twice cut. And this is a little too bright, but at the base of the pinnae are little tufts of hairs, which do not occur on the fern that looks most like it. Cinnamon ferns have hairy armpits. Here's an interrupted fern that looks a lot like the cinnamon fern, and this also can get to be 7 feet tall, or more commonly 3 feet tall. It's called interrupted fern because of this interruption in the pinnae. What's happening here is that these are fertile pinnae, and these are all sterile pinnae. And the fertile pinnae, once the spores get ripe, they shrivel up and fall off and try and scatter the spores, which they have to do very quickly. This produce green spores, and they have to germinate in the next few days, or they'll die. The easiest way to distinguish between cinnamon and interrupted fern is, of course, when their spores are ripe, when they either have the cinnamon stalk or the interruption is visible. But you might see a whole colony of either one that isn't fertile. And cinnamon fern, if you get the timing wrong, it won't have the cinnamon stalks. It just shrivel up by late June. And the interrupted fern, I've seen whole hillsides where none of them were fertile. They just weren't getting enough light. But you can still tell the difference by how sharp they are. This angle to the tips of the pinnae and also to the frond, that's like less than 30 degrees. That's very sharp. Interrupted fern can be more like 90 degrees. This is all very blunt. And you can get an eye for it. The color can be a little different. I don't know if you can see, but this is a more glossy finish, and this is more matte. They often grow near each other. They like wet. Cinnamon likes wetter than interrupted fern. These two and the other Osmunda, some people call this one Osmunda strom, the genus now, but they're certainly in the same family, and I think they really should be in the same genus. These are ancient. There are very few plants that can be found on every continent. The trick being Antarctica, where hardly anything is found except for large layers of ice. But if you look under the ice at the rocks and the sediments, at the fossils, you can find some fern fossils from when the continent of Antarctica wasn't at the South Pole, it was at the equator or near it. And these same ferns were growing there 200 million years ago. These species have not changed. in the last 200 million years. Somebody looked with an electron microscope and could not see any difference from the current ones. Looks like I have 10 minutes to do the rest of the species, so I'll hurry up. Here's Marsh Fern. It's like New York Fern. It's exactly twice cut, likes very wet areas, the very edge of a pond, or even the basin of a vernal pool once it's dried up in the summer. Widest near the base. These pinnae aren't very disciplined. They just go any direction they want. They don't lie in a plane. And it has the same little white hairs as New York Fern does. They're both Philipterus. This is Philipterus palustris. But these aren't on the edge. These are in the middle. But look at the veins. If you just hold the frond up to the sky, you can see through it and see the veins. And that one's forked. And that one's forked. New York Fern wouldn't do that. Plus, this doesn't have the tiny pinnae going down to the ground. Here's a twice cut fern. This is the other Osmunda. This is Osmunda regalis, royal fern. And some people think of the fertile pinnae that grow at the apex as a crown. And so they call it royal. Other people call it flowering fern because this looks like where it would grow a flower if it were a flower. This is a more normal view of it. It likes very wet. It's a wetland obligate. All the Osmunda grow in clusters. This can be in 2 feet of water. Doesn't mind a bit. They're very small, are the fertile pinnae at the top. Here's fragile fern, actually Cystopterus tenuis, which is the kind of fragile fern we have around here, Mackay's fragile fern. Likes to grow either hanging down or horizontally out of cracks and rocks, and again, rocks that aren't too acidic. That's Cystopterus fragilis, and it's a little shorter, little different shape. It does grow in Massachusetts, but it's much more common, at least in my experience, than Cystopterus tenuis is. Here's a common fern. This is a wood fern, a Trioptarus, and it's fertile. And there are the fruit dots. Why do you suppose they call it marginal wood fern? These sori are right on the very edge of the pinnules. Hybrids of this fern also have that same feature, not quite as extreme, but it's a good way to identify some hybrids. Here's what it looks like from the top. It does grow in the cluster. It's twice cut, could sometimes be a 3rd time cut. Often these will be scalloped a little bit, but it's basically usually twice cut. Here's another fern called lady fern. It's almost 3 times cut, grows in sort of a cluster, not a really tight one, has a rhizome that sort of angles up and moves along, and most of the fronds come out of the same portion of it, but they don't always bother facing each other. This is one of our most common ferns, so a number of particular areas, it's might have a hard time finding one. In the Haunton Park, there are a few places where it grows, not very many. What I mostly use to identify it are these long, narrow pinnules. And then these, when it's fertile, the sori aren't round. And they're not even straight lines, these little curved lines like comma shapes or J shape. And I think of this pattern as like a herringbone tweed. And except for a silvery glade fern, other ferns don't look much like that. Also, the endowment, the armor that it has to protect the fiddleheads, are scales. They're narrow scales, and they're scattered fairly evenly. And the books will say that they're black or dark brown, which might be true, but they can also be pretty much any shade of brown, including very light brown, in which case they get very hard to see. So here's hay-scented fern. It's one of our most common. It's the closest thing we have to an invasive species, or at least very aggressive. It will invade, but it's not foreign. It's definitely a native fern, at least to the extent that all our ferns have moved back here in the last 20,000 years after the ice receded, but pretty soon after that we had hay-scented ferns. They have these hairs. There's short hairs with little spheres on the end called glands. That's probably why it's called hay-scented, is because in the fall these break and release substance. It's aromatic. There are these long, straight hairs. If you can see both kinds of hairs, then you know it's hay-scented fern, but basically, if you see it growing in just this mass, that's pretty much proof that it's hay-scented fern. Likes sunlight, likes dry, doesn't mind poor soil. If you plant it in your garden, you should have like walks or walls around it if it gets light. If it's in the shade, it can die out, but if it's in the light, it gets very aggressive. Here is another wood fern, Trioptarus carthusiana. This is Spinulos wood fern. Notice that these basioscopic medial pinnules are longer than the adjacent ones. All the lower downward facing pinnules are longer than the upward facing ones, the acroscopic ones. But this is true about 80% of the time, but it's not entirely foolproof. But if you have a colony, a station of them, look at more than one plant, and if they're mostly longer and also spreading apart a bit, then that's Spinulos wood fern. Cold Spring Park, if you get into the swamp, it's just full of these. But often, well, no, that's still Spinulos wood fern, and it's the base that you look at to see those longer pinnules in the middle. Here's evergreen wood fern, or intermediate wood fern, Trioptarus intermedia. The basioscopic medial pinnules are shorter than the adjacent ones, though still longer than the acroscopic ones. And all these wood ferns, marginal wood fern too, have very coarse and profuse scales that cluster more near the base of the stipe and get less abundant farther up, which is different from the way lady fern does it. Here's a very triangular fern. This is Bracken. This does not grow in the cluster at all. It's very good at sending out horizontal rhizomes. It can even go under the road and up the other side. Doesn't have to reproduce sexually, and doesn't very often, though one did in the shade in my yard this year, but usually it takes pretty good growing conditions, good light for it to bother creating spores. It's so good at vegetative reproduction, has the two lowest pinnae are each about the same size and shape as the whole rest of the frond blade. So it has this triangular shape. Here's what it looks like when it is fertile. The edge of the pinnule curls over. It's called a false indusium. That's just a bug. And you can see the brown inside the curl, which are the sporangia. Here's an oak fern, and it has sort of that same triangular shape, except these stems are all green. Oak fern are black, or very dark anyway. It's also a much more delicate and shorter fern, though a baby bracken can resemble an oak fern. And they tend to grow in colonies. Even as a fiddlehead, they have this three-part shape. There's the same northern maidenhair fern, very unique shape, with purple and very stiff stipes that Native Americans used to make baskets. And even the next spring, you can still see these stipes above ground. Here's Ebony Spleenwort, once cut, the same sort of little ears, auricles, that Christmas fern has, but this has black stems. This could be a foot tall or maybe less. There it's growing in the ground, but often it grows on rocks. This is maidenhair spleenwort, very pretty fern. Gets stolen sometimes, it's so pretty. Here is the broadbeach fern I mentioned, where it's not cut all the way to the rachis, even between the first and second pinnules. And the basal pinnae are much more developed than the other pinnae. And last of all, here's Massachusetts fern, which is not terribly common, but I put this slide in because last week I found another station for it in the swamp in the middle of Cold Spring Park. And that's the two stations I found in that swamp are the only two stations I know of in Newton. Anyhow, we're out of time. And
thank you, Don, for that absolutely wonderful look into the world of ferns and for what they've done for our world. We really owe them a lot. Now, let's go to some questions. We're going to start off, Don, with a mystery that Pat gave us near the beginning of this. She says, I have what I've been told is an invasive fern in my garden. They are scattered type, and the fronds emerge from a rather thick rhizome. Reminds me of an iris rhizome, which is fairly shallow in the soil. These ferns take over other plants. How do you think they came to my perennial garden? And what do you think they are? And she also added later, right now this invasive fern has fertile fronds with spores visible.
well, I would suggest that she send me a photograph, especially of the underside with the spores. My website has my email address, and that would give me a better shot at identifying them. The most aggressive fern we have is the Scented Fern, and I'm assuming that that's not what she has, because she talks about thick rhizomes, and it has, I think, rather thin rhizomes. Lady Fern, Bracken, Sensitive Fern are the ferns that would just normally pop up in your yard just from spores blowing in. Any fern could, if it finds the right sort of habitat once it's there, but those are the ones that are common. But aggressive and thick rhizome, I don't know. Mystery is correct, but if she sends me some pictures of it, I would have a better shot.
Okay. We will be sure to share when we send a note to everyone afterwards. We'll share your address yet again. Anne asks us, do you have a field guide to New England ferns that you recommend?
Well, the Peterson field guide is pretty good. The one that I helped edit that was rewritten by the two women at the Wildflower Society at the Garden in the Woods. That was originally written in the 50s by Boughton Cobb, or that's the last version he did, has wonderful drawings and diagnostic characteristics. A lot of the species names, the scientific names, have changed since the 50s, and so that rewrite was done early in this century. But there's a cute little book, very recent, self-published, out of Vermont. I'm not sure I can quote its ferns. Something like the easy way to identify them.
Okay. Maybe we can get the specific information and send that out in our afternote, our post note too.
Certainly.
That would be awesome.
I do have the information somewhere.
Terrific. Ted Kuklinski says, not a question, but a comment of thanks. Having submitted some unknown fern pictures to iNaturalist, I noticed that Don Lubin weighed in with the ID. I've noticed that too, Ted, and I don't think Don has any idea he's responded to mine because I use a different name. And it's all, if you put a fern up there, he responds. It's wonderful.
I would have said hi if I'd known it was you.
Linda tells us that Brooklyn Botanical has a good fern booklet too. We can try to put that in our list. I'm making a note here so we don't forget it. Thank you, Linda.
I have something of a bibliography on my website, but I'm not sure it's up to date.
We'll check that too. Melissa asks us, can ferns be split divided?
Sometimes. If there's a patch of them and you can dig up enough of the rhizome, they can survive. You want about a foot diameter of soil plug and maybe almost a foot down. You have to get most of the roots, and you want to transplant it without breaking the delicate little rootlets. I tried a long time to transplant bracken and finally succeeded by getting the very end of a rhizome. They're long, and if you take in the middle, it's almost impossible to get enough roots for it to survive. You have to get about 6 feet of rhizome. Most ferns, like if there's a big clump of, say, lady ferns, you could probably transplant a piece out of it, but you have to get enough roots, and whatever fronds are there when you transplant it are going to die back, and you're counting on the new fronds that will grow up.
So a walk we need someday in the future, or a tour, is of your garden with all your ferns. That would be awesome. What do you think are the best ones that you found to grow in your own garden?
Well, lady ferns will propagate by themselves. They're very good at blowing down the side of the house and around the corner in the back and down the street and halfway down the block. The spores are not as finicky. I should say that I'm sorry that our walk to Webster was canceled early this June. I was looking forward to that. Maybe we can do that next year or sometime when people can get back together.
Let's plan that for as soon as we can gather. I know when you mentioned lady ferns, they always sell them at, it used to be Garden in the Woods. Well, it is still Garden in the Woods now, Native Plant Trust's Garden in the Woods. So it's an easy one to get right around here too.
Even places like Gurney's or Mahoney's will sell you lady ferns. Hay-scented fern, there's lots of it. If you put it in the sun, it will grow easily.
I get tons of sensitive fern. It takes over and everywhere. Anyone wants sensitive fern, let me know. I will share.
You must have wet space for it to grow.
I don't, but they love it here.
Okay.
Linda's asking us, don't lady ferns have red stems?
Some do. Most don't. Most have green stems, but they're very pretty when they have red stems. There's a form, rubella, which has red stems. Someone who taught some classes once said that red stem lady ferns and Thyrium felix femina rubella aren't exactly the same groups, that there's some distinction, but I never knew what the distinction was. But yes, you can see sometimes deep burgundy, sometimes more of a pink, but just beautiful red stems and lady ferns, but it's less than half, much less than half of them.
Fascinating. Well, I have one last question, which if we're not limited to Newton, and I've gone on some wonderful, way back in the day, I've gone on some wonderful Native Plant Trust walks that you've done, but they've been far. We've gone places like Rhode Island. If you were to be not limited to Newton, but you could range 30 miles, where would you go?
The Blue Hills. There are three main places in the Blue Hills. In the northwest corner, west of Unkwity Road and just north of North Border Path is one of the richest places for ferns around. Where the pipeline crosses Pine Tree Brook is another good area. And then around the AMC camp near Ponkapog Pond. Are all very rich. The Fells has some good ferns. Mount Wachusett has good ferns, but it's hard to lead a trip there because they're scattered about. You can't get a lot of diversity in a small area. We did do a club moss walk there once, but with the ferns, it's tough to get many in one spot.
You know what? I lied. I said that was the last question, but two more have come in that we're going to try to squeeze in here.
I'm here.
Anne asked again, what time of year do you transplant ferns? Spring before it breaks ground?
I'm not aware that it matters very much. They probably, like bulbs, shouldn't be transplanted immediately before a frost, or at least a deep freeze. They should have time to set their roots before they go dormant. But early spring, late summer, I don't think it matters too much.
Great. And Kelly has a question. If you forget about all they've done for us in the past, keeping our world alive, what is the big benefit of ferns?
Well, they look pretty. I mean, we may have another mass extinction and need them just to recreate the ecology. I wouldn't be too surprised if that is what happens. So I sort of still have faith that people can prevent that from happening and come to their senses. But yeah, just driving around, roadsides would look very different without the ferns growing along the edge of the highway. Or walking through the woods.
Yeah.
Maybe it's idiosyncratic, but I really like how old they are and how finely cut their shape is.
Linda points out, oh, sorry.
If you eat a lot of fiddleheads, you'd miss that without ferns. And the flower arrangements really do look better with some leatherleaf fern and with the flowers. But no, their economic significance currently is not very great.
Linda says that she thinks wood ferns are the best in bouquets.
Well, if you're not going to get the leatherleaf fern from Florida, the wood ferns are pretty robust and last for a while. And if you're going to cut your own ferns from your yard, wood ferns are a good choice.
And Catherine says that ferns are the saviors of her very shady garden.
Some ferns will grow just fine in medium shade. Christmas fern is good for that, or Japanese painted fern. Deep shade, mostly even ferns won't grow there.
I spent this year pulling up all my Japanese painted fern. I apologized to it. I said we'd had a relationship for all these years, but I'm trying to go to native ferns. That was very tough.
Oh, Garden in the Woods did the same thing.
Did they?
Yeah, I have some. I'm not being quite so
ruthless, cruel,
or limited in choice. I have some other Asian ferns and have had many more, but the native ferns, the ones that are native to at least New England, seem to do better than foreign ferns. And for that reason alone, one might want to grow mostly native ferns, though I don't personally know any good reason for pulling up Japanese painted ferns. They're pretty robust.
They come back. They're indomitable. They will be back. I have faith. Well, this was just amazing, Don. Thank you. As Don has said several times, if you have more questions, you can submit them to him, and we'll give you the address again, but it's don@nefern.info. Want to thank you, everyone. Thank you most of all, Don. This was an amazing night, and we hope to see everyone again soon.